Good morning, student. In lecture 6, unit 2 solution, today we will discuss azeotrophs. Today's topic is azeotrophs. In last discuss the ideal and non-ideal solution. We know very well azeotrophs are formed by the non-ideal solution. Ideal solution never forms azeotroph. So azeotrophs is formed by non-ideal solution. That means azeotroph is a mixture. We can say it is a binary mixture. So what do you mean by azeotrophs? The first point is it is a binary mixture. Binary mixture. Binary mixture means it having two components, one solute and second one is solvent. So it is a binary mixture. Now, second point, we know very well the mixture in which the component having a difference in boiling point, then they can be separated by distillation method. More volatile component will be come into vapor phase, and finally temperature decrease, it will be condensed and they can be separated out. That means mixture having different composition in liquid phase and vapor phase. Now we have then binary mixture subjected to distillation, so it having same composition. It having same composition in liquid phase and vapor phase. So same composition. Same composition in liquid phase and vapor phase. Again, azeotrophs. Azeotroph having a constant boiling point. That means it boils at a constant temperature. That means you can say it is a constant boiling mixture. That means constant boiling mixture, constant temperature boiling mixture. That means boiling point becomes constant at particular temperature. It is boiling. So this type of mixture is known as the azeotroph. That means it is binary mixture having same composition in liquid and vapor phase, and constant temperature boiling mixture is known as azeotrophs. Now, it having same composition in a liquid phase and a vapor phase. That means it cannot be separated by distillation. Otherwise, we can say fractional distillation. So it is not separated by fractional distillation. That means once the mixture forms azeotrophs, then the fractional distillation is carried out. It having same composition in liquid and vapor phase. So no further separation is possible by fractional distillation. Now, azeotroph formed by the non-ideal solution. So based on this, azeotroph having two types. Azeotrophs. Azeotrophs, otherwise you can say azeotropic mixture also. That means it is binary mixture. So, azeotropic mixture. Now, azeotrophs can be classified into two categories. first category is minimum boiling azeotrophs. Minimum boiling azeotrophs. And the second category is maximum boiling azeotrophs. Maximum boiling azeotrophs. Now, which type of non-ideal solution forms minimum boiling azeotrophs? So, minimum boiling azeotroph means boiling point is lower. That means obviously vapor pressure will be more. That means the solution, the non-ideal solution which show positive deviation from Raoult's law. That means positive deviation from Raoult's law. This type of non-ideal solution forms minimum boiling azeotrophs. So obviously here the non-ideal solution having negative deviation from Raoult's law. Negative deviation from Raoult's law. Then it forms maximum boiling azeotrophs. Why the solution having positive deviation from Raoult's law, so minimum boiling azeotrophs? Considering the example. Now we know very well one example of positive deviation from Raoult's law is ethanol. That means ethanol plus water. They form positive deviation from Raoult's law, non-ideal solution. Now ethanol having boiling point 351.3 Kelvin, while water having boiling point 373 Kelvin. Now at the particular composition they form azeotrophs. At the particular composition, so when ethanol having 95% and water having 5% mixture, when they are separated by distillation, then it forms azeotrophs. That means in azeotropic mixture 95% ethanol is there and 5% water is there. Now when this composition is achieved, it having boiling point, not constant temperature boiling mixture, so it having temperature boiling point become 351.15. 351.15. That means now when this composition is achieved, this mixture boil at this temperature and it having same composition in liquid phase and vapor phase. That means no further separation is possible. We can separate maximum 95%. Now this mixture, when this composition is achieved, having boiling point 351.15 Kelvin. That means this boiling point, that means boiling point of azeotroph, is lower than the boiling point of the each component present in azeotropic mixture. Here 351.3, 373. It is lower. Therefore, it is known as minimum boiling azeotrophs. Now here example. So negative deviation from Raoult's law. Considering the example nitric acid and water. Nitric acid and water forms negative deviation from Raoult's law. Water having boiling point 373 Kelvin. Nitric acid having boiling point 359 Kelvin. Now when distillation is carried out, then when the composition of the mixture becomes nitric acid 68% and water 32%. When this composition was achieved, then constant temperature boiling mixture, it becomes constant temperature boiling mixture. In vapor phase and liquid phase, composition becomes same. That means no further separation of nitric acid is possible by distillation method. And this mixture, when this composition is achieved, then this mixture having boiling point 393.5 Kelvin. This is constant temperature. Now this mixture boils at this temperature and same composition. In vapor and liquid phase, so no further separation is possible. Now this boiling point value is greater than the boiling point of each component present in azeotropic mixture. So here 359 Kelvin, 373 Kelvin, and here boiling point of the azeotropic mixture is 393.5 Kelvin. That means higher than the top both the component. Therefore, it is known as maximum boiling azeotropes. So this is the discussion of azeotropes and the types of azeotropes.